to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, and you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
So hello everyone, and thank you for joining my TestCon session today. I'm going to be talking about techniques for effective test automation in DevOps. And personally for me, and maybe for many of you attending, I come from a background where test automation meant automating huge regression test suites that were executed at the end of long development cycles. And unfortunately, if you go out in the world and try to learn about test automation, a lot of that information that you're going to find was born out of that mindset. And there's a lot of problems with that approach, but really what's relevant to us today is that legacy approach to test automation is just absolutely counterproductive to what we're trying to get out of DevOps. So we'll be talking about how we can approach automation in a way that's much better aligned to an agile or DevOps delivery cycle. So before we get started, I'll tell you a little bit about myself. I'm CTO of Utopia Solutions, a software quality and testing service provider. Personally, I've been involved in quality and testing for over 25 years, most of that time focused on implementing test automation. And certainly my thoughts on test automation have evolved over that time. But I've really developed a passion for helping organizations implement automation the right way, and that really is just the right way for their specific organization and the way they deliver software. So briefly, the topics that I'm going to touch on today will include a short intro on the importance of test automation in DevOps. Then we'll spend a bit of time talking about some obstacles and anti-patterns that we can fall into. And then I'll spend the rest of the time focused on what I call the 3 pillars of effective test automation, which are scope, the approach, and then test environment and data management. And while we're going to talk about these practices in the context of DevOps and how they help us move towards continuous testing, they're certainly applicable to test automation in general, really independent of your development processes. So the goal behind the DevOps movement, at least one of them, is to reduce development cycles and more frequently release high-quality software that is closely aligned with your business objectives. And in DevOps, testing is moving from being part of the development cycle to something that happens throughout the cycle. But for DevOps to really achieve its potential, the feedback we get from our testing activities, they must be fast, accurate, and actionable. We can't be waiting for long, slow tests to run and then sift through piles of results to understand if the build is ready to be promoted. And we certainly can't be wasting our time chasing down false positives or negatives. And before we move on, I want to bring up, I think, an important point about quality and testing in DevOps. There's a common symptom that I see in organizations that are moving to more of a DevOps approach, where the idea is they want quality to become everyone's responsibility. But the problem that I see often with that is that when something becomes everyone's responsibility, it can often also become no one's responsibility. And this happens a lot of times in teams that have worked in environments where test automation was just someone else's responsibility. Maybe you had a center of excellence or a separate automation team. And then that mindset kind of continues as they move into DevOps, a DevOps model. But for test automation to succeed, it has to be a team effort. It doesn't mean everyone becomes an automation engineer, but it does mean that everyone understands that they have a role in contributing to test automation and of course, to product quality in general. So I think next it's important to understand the importance of test automation in DevOps. And a good way to do that is to look at this description here of required continuous integration capabilities from the DevOps handbook. And I've highlighted the important parts with respect to test automation. The first point requires that we have a comprehensive and reliable set of automated tests. And then the next point goes on to state that we need to have a culture that stops the entire pipeline when those tests fail. And this really starts to speak to the importance of reliable automated tests, which we'll talk about in some more detail later. But for now, suffice it to say that if we're going to pull the emergency brake when our tests fail, they better be reliable. And we're certainly not going to get too many chances to prove our reliability if we keep failing over and over again. All right, I think another way to look at the importance of test automation is to look at the level of automation across the different categories of DevOps performers. This is some data from the 2018 State of DevOps report that shows the level of manual work across different categories of DevOps activities. And as you can see, the high and elite performers have quite a bit of test automation as well as other automated activity compared to the lower performing counterparts. So great. What's the big deal, right? All I need to do is automate my existing tests, and of course, how hard can that be? I need to buy or download one of the more popular tools. I build a framework perhaps, and I just start automating. You know, after all, it's only testing, right? But before we go any further, I think we should look at some statistics that are really pretty alarming if you consider all the time, money, effort that's being poured into test automation. So first, let's look at this from the World Quality Report that says the level of test automation in general is below 20%. And that the context of that statement is that of all the potential testing activities that could be automated, less than 20% are. Now, well, again, that's a pretty disappointing statistic considering the vast amount of resources that we put into test automation. I think it also points to a huge opportunity, and we'll talk more about how we can take advantage of those opportunities in a bit. The report goes on to say that while the level of automation has been on an upward trend, so we're pouring more and more efforts and resources into test automation, the value that we get back from those resources and that investment remains largely unchanged. So again, even as we pour more and more money, effort, time into test automation, we're not getting anything more back for that investment. And finally, well, I couldn't find a reputable published source for this statistic. I think it's pretty well accepted just in general around automation implementers, and that's that 80% of test automation implementations fail. So 8 out of 10 of us on this session today are likely or have the opportunity anyway to fail in our next automation endeavor. And while I'm not necessarily talking about huge disaster type failures, but if you put failure in the context of we're not getting the results that we desired, we're not getting a positive return in quality or other characteristics, it's pretty well accepted that about 80% of efforts fail. And even if we can't all agree on the numbers, I think we can agree that there's a huge opportunity for improvement here. Test automation is not just a point-and-click solution to your testing problems, and the fact that we're doing DevOps or we're delivering software in a DevOps model certainly doesn't make it that way. So before we get into some common obstacles to test automation, I want to talk a little bit about a very common misconception about what test automation really is. First, looking at this definition of software testing, and you certainly may have a better one, but bear with me. We see terms like knowledge and experience and critical thinking, designing experiments. And we have to ask ourselves, is that what we automate when we say test automation? Well, of course not. Clearly, that's not what's being automated. If you spend any time in the software testing space, in fact, you'll see that there's a movement away from saying test automation and replace it with automation and testing, which I think makes it more clear that what we're doing here is applying automation principles to testing activities. And it may seem like semantics, but I think it really will help get rid of this this common misconception. So very clearly, I'd like us all to get on the same page in that we are not automating the testing. So as we talk about test automation for the remainder of this talk, let's understand that we're applying automation activities, automation principles to the activities that we perform related to testing as we move through our delivery cycle. All right, so if we agree that we can't be successful with DevOps without effective test automation, it's important for us to be aware of some common obstacles or traps that we certainly are or could anyway fall into. First is either too much or not enough information. Not enough automation. I see a lot of instances where there are just many automated tests that were created for no other reason because they could be automated. And that's really not enough justification. I see a lot of instances where I hear, well, we're running hundreds or thousands of tests every day, but this is really a quality over quantity situation. Second, very important, automating the wrong tests that aren't providing value or can't be reliably automated. That's just a waste of time, and automating for nothing more than the sake of automation. And we'll spend some time talking about how we can identify what the right tests are. Next, and this is a huge one, focusing on UI level tests only. And I think a big reason why we still see a huge focus on only UI tests is that a lot of us got our start in test automation or automation in testing back when automating at the UI level was really the only option we had. But the reality is these tests are the slowest, most unreliable type of automated test there is. I'm not saying we shouldn't have any. We still need to validate the mechanics of our user interface. But if you have 100% of your tests that are executing at the UI level, that's likely going to be a problem at some point. Next, and this is probably the biggest offender, is not having stable test environments or data to execute on. And we'll talk about this in a lot of detail a bit later. Next, not treating automation as code. We won't go into this really, but suffice it to say that if we're going to rely on our automated tests, at least in part, to assess the quality of our product, we need to treat the code that those tests are built on with the same care that we give the application we're testing. And finally, I see a lot of teams that build, at least initially, a successful test automation function, but they treat it more as a fire and forget solution. And especially in DevOps, continuous improvement is a very important factor and part of that culture. And those continuous improvement efforts should definitely be extended to your test automation efforts. So we've talked about the obstacles to success. Now let's see what effective test automation looks like. As I mentioned in the intro, I believe the three main pillars of effective test automation are scope, approach, or the method that we use to implement automation, and environment and data management. I think the scope and approach go hand in hand, so I'm going to talk about them together over the next few slides. So before we get into a detailed conversation about test automation scope, let's look at some trade-offs that we encounter in the DevOps delivery cycle. As we go further down the pipeline, we have, hopefully anyway, an increased confidence in our build's readiness for deployment to production. And typically those environments become more production-like as we go down the pipeline. The trade-off here is that as the test environments become more complex, the time it takes for those tests to give us the feedback that we need increases. So we end up with this constant battle between risk assessment and coverage and the desire to get fast feedback so we can move through the pipeline. As we'll see, this really highlights the need to think very critically about the types of test suites that we create and, of course, which specific tests we put in those test suites. So first, let's talk a little bit about how we can assess what test suites we need in our pipeline. Excuse me. So let's start with determining which test suites are important. And I think a good way to do that is to use a process that was introduced by Katrina Clokey. She's a wonderful book on testing and DevOps, by the way, and something that was further refined by a talk that was given by Ashley Hunsberger. And that's the test suite canvas. The idea behind the test suite canvas is to think about the important aspects of the test suite so we can first determine if we need it at all, and then figure out what it's going to do and how we're going to implement it. And this should really be a group exercise. So the entire team, not just the automation engineer, thinking about this in a vacuum, right? And it does a great job of getting the entire team thinking about the details associated with each test suite. It's easy sometimes to say we're going to have an integration, automated integration test or automated end-to-end test, but not really think about the details of how that's going to be created and how it fits into our pipeline, and ultimately who's going to be responsible for it. So let's take a look at each area of the canvas. First, we have purpose. So if we don't understand why we're building the test suite, it probably isn't important enough to be part of our pipeline. But you'd be surprised how many teams will create a test suite, again, just because they can. They have tests, they can't automate them, but not really thinking about the value that test suite will provide. Next is dependencies. So what systems or tools need to be in place for this test suite to run successfully and give us the information that we need. Next is constraints. So what in our organization or in our environment is preventing us from implementing the test suite in the way that we need to implement it. Next is pipeline and execution. So where will it exist in the pipeline? When will it be triggered? How often will it be executed? Next, environment and data, and we're going to talk about this in detail, but what environment are we going to execute this test suite in? And then how are we going to manage the data that's part of that environment? Ownership is important as well, and not just in a figurehead sense, but if something fails, who's going to respond and investigate those failures? Next is maintainability, and that's always an issue with test automation. But even in the case where maybe we have to hand off the test suite, hand off ownership of it, what do we need to be in place to make that process as seamless as possible? And finally, effectiveness. And this is really a metrics discussion, right? If we're going to invest and build and maintain this test suite, we need to make sure that it's giving us the value that we need from it continually, right? Not just, again, not just the fire and forget solution. I've created this test suite, I'm just going to execute it and not ever think about it again. So once you've gone through that process for each of the test suites that you think you might need as part of your pipeline, what we typically do is take each canvas that we've created and transform them into a single spreadsheet, so one row per test suite, so we can more easily see the universe of testing that we've mapped out across our pipeline. It can also help us identify common constraints or dependencies across multiple test suites, right? And then if we can handle those dependencies or constraints, we're unblocking multiple test suites. Once we've done that, we have a good idea of the test suites that we need. It's a good exercise to then map those test suites across the pipeline, so we can start to visualize the flow of our builds with respect to our risk assessments. This also helps us understand if certain test suites must be run sequentially or if there's an opportunity to run them in parallel. So we've talked about how we can identify test suites that are important to our pipeline. Let's look a little bit deeper and see how we can evaluate if a test is worthy of being part of our test suite in the first place. If the tests are going to be part of a continuous testing environment, they need to be run possibly anytime on demand. And as we already discussed, they need to provide fast, accurate, and meaningful feedback. And Bas Dijkstra, who's an automation engineer in the Netherlands, has come up with a great acronym for reminding us about the qualities to look for when determining if your automated tests are quote unquote fit for continuous testing. And that's FITR. It stands for focused, informative, trustworthy, and repeatable. So let's talk about focused first. This really refers to testing functionality as close as you possibly can to where it's implemented. So let's say, for example, the purpose of a test is to verify that a tax calculation that's performed inside of an API or a service. And let's also say that I have a test that attempts to do that by checking the value on an invoice field, invoice total field on the user interface. So if the test passes, we're probably okay. But let's say now that we find an issue, maybe that total invoice value isn't what we expected. Granted, it's not the best test design, but for the sake of argument, if we try to verify that functionality inside the API at the UI level and we find an issue, there could be a lot of reasons why those values don't match. Could be a data setup problem. It could be a pricing on your invoice, etc. We don't know what the problem is, right? And we have the point is we now have a long investigation to try to figure out what happened. Whereas if we had tested very close to where that functionality is at the API or service level, we'd likely know exactly what the problem is, certainly where the problem is anyway. Next is informative. And I think first, if your tests are focused, that will help them certainly to be more informative, but we can do more. First, I think for the test itself, it should be as self-documenting as possible. Someone looking at the code that implements the test or the test itself should understand its intent. And probably even more importantly, the output or the logging and the reporting that are created as your test suite executes should provide feedback as to what happened, especially if an issue is encountered. Right? A very common example for UI level tests is that we can't locate an element on the page or the screen. When that happens, I don't want to see a stack trace. I want to know what field I was looking for. I want to know what locator I was using to try to identify it. And I want to see a screenshot. And that, a high percentage of the time, is going to give me all the information I need to understand what happened. Next is trustworthy. And this is a big one. If you're going to be part of a build pipeline, and certainly if part of your culture is to stop the process if your automated tests fail, the tests have to be trusted. If they can't be trusted, you're going to lose that privilege of being part of the pipeline, or those tests are just going to be ignored, and really either option is not good. And finally, we have repeatable. If your tests are going to be kicked off, again, automatically by some event that we aren't controlling, they need to be ready to go. And this usually means that you've taken care of business with respect to test environment and data management. And again, we'll talk about that here next. So one of the most common phrases we hear when trying to understand and reproduce an issue when automated tests fail is, well, it worked on my machine. And as we just discussed, test automation scope and approach are certainly obstacles to effective automation. However, as again, the World Quality Report states, test environment and data continue to be the top challenges to effective test automation. And again, this has been true for quite a while. You can do a great job of figuring out what test suites you need and what tests should be in those test suites, and then build a very efficient, effective framework to execute them. But if you don't have a stable test environment and data, it's not going to matter, right? And so the root cause of, well, it worked on my machine, is often related to some environment or data issues. So over the next few minutes, we're going to discuss what we can do to remove that phrase from our testing vocabulary. So let's start by looking at the spectrum of test environments and data situations that we might encounter. At one end, we have the good old static shared environments that are created and sometimes seen to persist forever. And I still see a lot of organizations implementing DevOps processes and still working, though, in this shared static test environment situation. And I've added stale to that because I think by their very nature, the data in these environments often becomes stale over time. And this type of environment will lead very often to a cascading set of issues. Because they're shared, they can cause instability in the data, right? Maybe someone changes data that's needed by someone else, and depending on the approach to managing the data, and very often there isn't one, that data is probably stale. We also have scheduling conflicts, right? Maybe UAT is trying to do their work, but someone needs to run a load test. Maybe training needs to use the environment because the environment they have is in even worse shape. And it's probably not very production-like, very often not in size or shape, but also no one might ever know really what the configuration is at any given time. And those issues are the root cause of many of the automation challenges that we referred to earlier. Data instability results in unreliable execution. Because we can't rely on the data, we're forced to set up all our data each time we want to execute, and that doesn't sound like very fast feedback to me anyway. Data or configuration issues can result in false positives or worse, false negatives. And all that results in a really long time for analysis because you're never quite sure if issues are actually issues, and if they are, what caused them. So let's take a look at the other end of the spectrum, where we have dynamic, dedicated, fresh environments. And they're dynamic, so perhaps we can create them on demand using virtualization and infrastructure as code techniques. Because they're easier to create and manage, we can likely have more of them and maybe dedicate them to a specific function like a specific automated test suite and eliminate all the issues associated with sharing environments. For the same reasons, we can make them production-like if we want, or at least be in a state where everyone is working in separate but identical environments. Again, going a long way to removing the, well, it worked on my machine problem. And since we're creating them on demand, we might as well ensure that those environments have the data that we need in the state that we need it to be in. Now, before I go on, I'm not naive enough to think that we can snap our fingers and automatically get to the right side of this spectrum, because depending on a lot of factors, cost, complexity, etc., it's just not that easy. But part of our continuous improvement effort should be to continuously move towards that ideal state, because the closer we get to it, the easier the other activities become, and we start to remove a lot of those obstacles that are preventing us from having effective test automation, and then of course the benefits to our delivery cycle in general. Okay, so let's move on to test data. And I'm sure we can all relate to stories of testing issues that we've encountered that were somehow related back to data. Again, if we look at the World Quality Report, the biggest data-related challenges were first keeping data in sync with tests, right? And this is the situation where the tests are inputting data that is no longer appropriate given the current state of the system under test, or the tests are expecting a data response from the system that is different from what it's actually giving. Next is the lack of data for complex integration testing. And typically, right, these are tests that are maybe further down the pipeline, but could be something like a long order management flow, for example. Finally, and I think very similar to the last point, maintaining consistent data across systems under test. And to me, this speaks more to data in external services or other systems that make up an end-to-end business flow. But independent of the specific challenge, this all results in the inability to reliably execute automated tests on demand, right? And that flies directly in the face of what we're trying to accomplish with our testing activities in a DevOps environment. So all of this points to a test data management strategy or the need for one. And if you remember back to the test suite canvas, one of the sections talked about data. So this is something we need to think about before we start building framework and tests, and certainly something that has to be done before we have to execute them. So as we think about our test suites and subsequently the tests that we're going to add to them, we need to pay attention to the data that each of those potential tests may need. I think it's very easy to just begin creating tests and almost subconsciously include the data. However, we really have to understand what I call the dimensions of that data. And these are essentially the attributes of the data that describe how it lives and behaves in your system. So first is the type of data. In most cases, this means if it's structured, for example, a relational database, or maybe unstructured. Of course, the value of the data, either a specific value or a class of values, is important. Time is extremely important. A lot of times when you have tests that have passed for a period of time and then suddenly start failing, time turns out to be the culprit. Maybe the data expired. For example, an insurance policy reaches expiration date. The inability for data to be reused or not is important as well. For example, if I'm testing an e-commerce system, the account I'm using to purchase items can be reused. However, if I'm testing shipping an order, I can only ship that order once. Volume of data is also important. Certainly, this almost always comes into play for load testing, but there's some subtleties here. Sometimes you need a specific data value to represent volume, right? Maybe think about some level of inventory or some level of available credit. And finally, where does your data live? If you're going to possibly develop a strategy to manage it, you need to understand where it's coming from so you can evaluate your options for controlling it. So let's talk about test data management strategy. There's no step-by-step, one-size-fits-all recipe for a test data management strategy. It's going to vary quite a bit from organization to organization based on where the data lives, what the dimensions are, the state of the test environments. Even what works for a specific e-commerce platform in one organization will likely not be appropriate even for the same e-commerce platform that's being implemented by a different group. So really, it's better to talk about potential techniques so we can expand our tool belt when we dig into our own situations. So first, let's look at some things we can do at the application level. Of course, we have the data refresh, right? Essentially replacing the current data in your environment with data from a known state, sometimes production. This is a fairly common approach, but the way it's typically done doesn't work very well with DevOps, right? Typically that refresh is done at some cadence that is just way too slow for DevOps environment. Remember, we want to be able to execute these tests on demand. Also, it may not work well for integrated systems that can't easily be refreshed at the same time and keep their data in sync. Next is a technique that I see used quite often, and that's what I call data partitioning. And this is where you dedicate certain data objects for use only by an automated test suite, or a certain automated test suite. Maybe certain accounts or certain warehouses that are only used by a specific test suite, or even specific tests within the test suite. This can really help with issues related to shared environments, assuming that other activity, in fact, does not use the data that you've dedicated. You can also use dedicated environments for test automation, and of course, this depends on a number of factors, again, like complexity and cost. And while those could be effective, they may not be as flexible and nimble enough for DevOps. But there are some things that we can do more at the test suite level that lend themselves a little bit better. First, we can have our tests create the data that we need prior to execution. This is often combined with data partitioning to further lessen the chance of data-related issues. Similarly, we can have tests that clean up after themselves when they're done, and this is typically done in conjunction with pre-test data creation. We can create our environments on demand, and we can create the data in the state that we need it, and then maybe even blow it away when we're done executing. Finally, and this is becoming very popular, is to build capabilities into our frameworks that handle data that changes over time, for example, or follow some rules that make it impossible to use the same data for each execution if it can't be reused. And of course, we have full-blown test data management solutions that were purpose-built for managing data, especially in complex test environments. Of course, service virtualization and mocking as well can help us deal with some data issues, especially in upstream environments. But really the important takeaway here is to understand that first, test data management is important to test automation, and that we have a decent tool belt of techniques that we can use to address it. But in order to get there, we have to understand our application, how data behaves in our application, and of course the environments that we're working in, to begin to discern what techniques are going to be appropriate for you. All right, before I move over to questions, I wanted to focus on some key takeaways from the talk. So we talked about a lot of information, but I think these are really the key points that I want you to walk away with. First is that effective test automation is absolutely required to achieve success in DevOps. Without effective test automation, testing will become the bottleneck in your pipeline. And next is to think very critically about your scope, right? It's not a how many tests can we automate game. It's how can we get high value tests automated so it gives us the feedback that we need in a very timely manner. You absolutely have to understand your test environment and data requirements, and then develop a strategy to manage them. That is the year after year the biggest obstacle to effective test automation. Next, and this is very important, is that you need to extend your culture of continuous improvement to your test automation efforts. I think if you do any reading or research on DevOps, culture always bubbles to the top as kind of the foundation of a successful DevOps environment. But I still see sometimes for test automation that process or that culture not being applied. So very important to continuously look at the way that you're implementing test automation and looking for ways to improve. And finally, and maybe to everyone's surprise, we did not talk about specific tools in a test automation talk. And the reality is, right, tools are the enablers of your test automation approach. They're not the solution. And I see a lot of implementations start off in the wrong direction because they're taking a very tool-first or a tool-centric approach. They've got a tool, they've got a framework, and then all of a sudden they start looking for things to automate. The reality is, what tool or how you build your framework is down the list in terms of what you need to think about, or the order you need to think about things to enable effective test automation. So again, thank you for attending the session. I'm going to take a look at, looks like there was a couple questions that were asked. First one is, says, how are you holding a production-like environment for testing? So from there's a couple aspects. For functional testing, right, when we say production-like, we don't necessarily mean size, right? That can be very, certainly very expensive, and obviously some complexity involved there as well. But in terms of configuration, that especially for functional testing, very often will prevent a lot of issues that are environment related. So if you're using infrastructure as code or other techniques to create your environments, and you're managing that code the same way you're managing the code of your application and controlling it, you can get very consistent environments across all the different types of activities that you're using. You can spin up environments that way that are in a known configuration. If you find an issue and you hand that issue off for someone to look at, you can essentially hand the environment off as well, and you can go a long way to eliminate the well, it worked on my machine. But good question. Says dynamic dedicated environments takes more time to set up and create than managing test data as part of test data in existing environments. Do you still recommend it? So I will say that a combination of managing your test environments, creating dynamic environments, and managing the test data within them is the ideal situation. It really depends what you're doing, right? If you're in a situation where you can't use virtualization technologies or infrastructure as code for your environments for whatever reason, you're just not there yet, or there's something that's preventing you from doing that. Yes, you can't get as far right on that spectrum that I showed as some others, but certainly there's organizations that are there, and they would argue that using dynamic, dedicated environments and creating them on demand is much easier than trying to manage test data in an existing shared environment. So yes, I would absolutely recommend that you endeavor to move as far right on that spectrum as you can. One last question. Looks like says, can we execute SQL to create test data for an on-demand environment? We don't have any REST API for or service to create test data. So yes, this goes back to what you need to understand what's right for you, right? And that's exactly why there's not a one-size-fits-all recipe for this. You need to look at your environment, what's possible in your environment, and figure out the best way to control your data, to manage your data. Yes, certainly applications that have robust API or service layer can use that to create data or to manipulate data for their testing needs. Some organizations even build APIs and services specifically for managing data. But if you don't have that, you need to understand what you do have and what options you have for managing that. Last question, this is what tools do you use to manage test suites or test cases? So that's a really loaded question. I just have a minute here. I would say it's less important what tools you're using. Now, certainly, you want to manage if your test suite is built on code, right? You've built a framework. You want to control that code. You want to version control that code. In terms of managing the test cases, the important I think the important aspect there is that you do have a place for those test results to go. You know, whether it's one of the add-ins for Jira, you know, Zephyr, whether it's a full-blown test management tool. It's really less important. It's more important that you're you know, you've thought critically about what tests you've created, and that you have a way to get the test results from your execution into into a tool that can kind of store them and trend them you know, historically. All right, so I am out of time. I'm going to move over to the Zoom chat and see if there's any questions over there. But again, thank you so much for joining and for interacting. Questions were great, and I hope you enjoy the rest of the conference. Thank you.